Alright. So I wrote this on this paper, but I'm starting with number 24. You might want to do some piece of notebook paper. I'm going to go through these kind of quickly because this is recent material. We're on number 24. I'm not going to actually work 24 and 25 out because it requires graphing, but we're just going to talk about what you would do for that. On number 24, what type of function is that? Exponential, so you would make a what? A table. And what numbers would you put in that table? And then you would plot those points, wouldn't you? Do we understand how to do that? Alright, number 25. What type of function is that? So once again, you would make a table. Put those numbers in. You could actually graph it and look at the table, but those how do you do 24 and 25. Alright, let's look at 26. What type of equations are 26 and right there? What type of Okay, guys, you're about to scare me to death. Brightest kids in school. What type of equations is number 26? Say it. Why is it exponential? Very good. There's a variable and an exponent. Don't play with me this morning now. Now, what's your first thing that you try with exponential? You try to get the what? Bases to be the same, okay? So let's see if we can do that. That's 3, 6 to 3 raised to 6 minus 3x. Can I get that to be a base of 3? 3 to the what? Negative 3. Now, since the bases are the same, I can ignore those and just say 6 minus 3x equals negative 3. Negative 3x equals negative 9. X equals 3. Can I get these two to be the same base? I can rewrite this as 9 to the what? Negative 1. 9 to the negative 1. So 2x equals negative 1. X equals negative 1/2. Number 27. We want to convert that to a logarithm. What form is it in right now? Exponential. So, do I use log or natural log? Natural log of 15 equals x because it's e to the x equals 15. So I converted that. Now I want to write this in exponential. That would be b to the 2/3 equals 49. Any questions on 24 to 28 so far? Are y'all good? You sure you good on the graphing part? We good on that? All right. Log base h. We want to find the value of the expression. 8 raised to what power will give you 1 over 5/12? Negative 3. Very good. E to what power gives you 1? 0. Very good. We want to solve this problem right here. Log base 8 of 8 over 27 equals 3. So it's in logarithmic. I'm going to put it in what form? Exponential. So I get x cubed equals 8 over 27. How do I get rid of that cube? Take the what? Take the cube root. What's the cube root of 8? What's the cube root of 27? There's your answer. It says rewrite each of these as sum or difference. Remember, that's your properties, okay? So I would write log base 19 of 18 plus square root of r. What would I put first? 1/2 log base 19 of r minus log base 19 of S. Now, if you wanted to put both of these in parentheses because they're together up there, that is fine, but you don't have to. I've seen it both ways, either way. Here, I got log. I'm sorry, I can't read my handwriting today. The 8th root of 15. So I'm going to do, how would I write that? 1/8 log 15 minus 2 log n plus log m. Ms. Judge, could you put this in parentheses? Yes, because that's together. Number 34 says write as a single log. That means it just wants one log. So it'll be log base A of m over n times what? K to the third. That's a strange one. I won't give you one like that. But you got your m over n because you got subtraction, so that's quotient rule, times k cubed. Is that coming back to y'all? Y'all good on those? Okay, we're going to pick up on that tomorrow. All right, let's check our homework. There's number 12. Tomorrow in your quiz, you have these two learning targets. I can solve a system equation. Let's look up here for a minute. Stop looking at homework. Look here for a minute. So, these are easy. What if you get a scenario of 0 equals 0? Infinitely many. If you get 0 equal to some number, that will be what? Okay. On this right here, let's say we have these first two. We select the first two, first in the middle. Let's say I wanted to eliminate the x. What would you have to eliminate on the second and third one? X. Does everybody understand that? Okay. And then we talk about performing operations with matrices. When you're adding and subtracting matrices, Jackson, when you add and subtract matrices, they have to have the same what? That means they look the same, don't they? And the way you describe matrices is by dimensions, row by column. Row by column. What's these individual numbers called in a matrix? Element. An element, okay? Now, in multiplication, you have to look at the dimensions and the inner number has to be the same. Does that make sense? Okay. All right, so there's number 12. You get 1, -4, and 4. How do I know how to put the numbers in what order? What order do we put them in? Alphabetical. Very good. There will be a homework check. All right. Are there any questions on number 12? All right. There's number 14, -2, 2, and 4. Any questions? Okay, there's your answer number 1. That was a pretty easy one. On number 3, remember, what does this minus do to everything in this matrix? Changes the sign. So that's why I showed you, I did minus, I come under, did plus, and change every sign of those elements, okay? A minus changes everything in there. So there's your answer to number 3. Are we good? Number 5 is pretty easy. Number 7 was easy. Just had to distribute the numbers on the outside and then add them. Number 9 is not possible. You cannot multiply these because these two numbers are not the same. And then in number 11, these numbers are the same, so you're going to produce a 1 by 2. So row by column, row by column. Y'all agree with those? You got 5 minutes to do this checkpoint. If I don't finish checking it, you keep your notebook open, don't close, because as soon as we're doing this, we're going to continue our note. Is matrix multiplication commutative? No. Yes. Oh. When this timer goes off, you should be done. Very good. If you're sitting at home watching the video, you can copy this checkpoint on a piece of paper and bring it to me tomorrow. You have 2 minutes remaining on this task. If you do not complete this task correctly in this amount of time, you come to 0 here tomorrow for practice. Well, middle and last. Middle number. First number. First number. No, first middle. No, middle, first number. No, correct. Yours. Correct. Okay, what's yours? I'm going to stop saying which digit because it's correct. You got to go back and look at your answer, but yes, you need to put one correct. If you're done, turn to page 3, ready to take notes. Go back and look at it, please. Good. Good. Zero here, go back. Do the first two, eliminate. Second two, eliminate. What did you do 29?
No, that's me with format.
Okay, go look at that step. But you need to put what you get on both of these. Right. Tell me, draw a line and tell me what you get. Put that one there. You skip the step.
No, I took them and put it
I need to see that so I know where to put them. Okay. Okay.
I just shut down all that.
Bring it to me. Guys, I told you yesterday, buckle down. That test, I've shortened the test to 17 questions Thursday. This is not the play week in math this week. Raise your hand if you still got your checkpoint. Okay. Turn it in, come 0 up here. All right. You have 2 of these on your test on. All right, and there's no partial credit on that test on Thursday. All right. All right. Turn to page 3. Let's look at these matrix equations. Sometimes these occur on the ACT. Like on number 10 right here, you have one row, not one row, 2 rows and 1 column, 2 rows and 1 column. So, Mr. Fisher, I thought there was 4 things. If they got plus and minus in those are considered one thing together. So 15 plus X is one thing, okay? So you have 1 row, 2 rows, 1 column. So you just set the corresponding elements equal to each other. So like 4X is sitting where this is sitting, so I'm going to set that equal to that. Bring the X over, it gives me 3X, so X equals 5. To find what Y is equal to, I'm going to say 5 equals 2Y minus 1. So I get X equals 5 and Y equals 3. On number 11, how many elements are in this matrix right here? 1, 2, 3, 4, and there's 4 over here. So how would I find out what x is equal to? I set this equal to what over here? 9. This, I would set equal to this. You can look at that and tell y equals what? -5. And this, we set equal to that. Is equal 6. Yes.
What about the 7?
7, since they don't have a variable in it, you don't have to worry about those.
You're right.
No. You're just worried about the parts that have a variable in it. These are not on your test on Thursday. I just want to go over them because they do occur on the ACT sometimes. Your quiz tomorrow will have this on here and those systems of equations on your quiz tomorrow. Alright, let's turn it over. This will be on your test. It says I can determine, or first learning target is I can determine the determinant of a matrix. A determinant of a matrix. And we only look at 2x2s and 3x3s. Alright. So, does anybody remember how to do that from last year? How to find the determinant? Diagonals, very good. Like on this right here, we cross multiply. What's 6 times 3? 18. And you always put a minus sign. What's -3 times 2? -6. That's a double negative, so your determinant is 24. What's 4 times -1? And what always goes here? Minus. 5 times 0 is? So your answer is -4. We're only doing the ones I'm circling. Now, those are easy, and you know that's occurred a lot more. You start seeing that on ACT, those type of problems. So those are easy points. Now, number 4 and 5 is a little bit more complicated. Now, we're going to go slowly on this. You need to watch my own steps on this one. You're going to break these 3x3s down to little 2x2s. That's pretty much what you do. You start with that first number in this corner. Can everybody see that? Okay. I'm going to start with that number. Okay, so you start with that number there. You pick the elements that are not in the same row or column as that number. So these numbers are these numbers. So you left with those 4 numbers there. Do you see that? That's what you put in here. Always a minus goes here. That's just the rule. Minus. Pick the next number, which is what? 3 across the top. Pick the numbers that are not in the same row or column. Row or column. So it would be this number, this number, this number, this number. Do you see that? Okay. You pick the numbers that are not in the same row with that 3 or column with that 3. So it would be these numbers. So you start. What's quick? Somebody got a comment?
Are we doing this for all 9?
Huh?
All 9 of the numbers.
No, just the top 3 numbers.
Okay, cool.
Okay. So, y'all did not do this last year? Oh, you talking about the little?
Yeah,
That confuses me. So, if you remember how to do that, you can do it that way. Because that confuses me. All right. Now, here I will pick 0 and -2, 4, and 6. Then a plus always goes here. And then I have a -1. And the four numbers there, I would put 0, -2, 2, 5. And then, guys, all you do is you find the determinant of each of those. So this would be like 2. 2 times 6 is 12, minus 4 times 5 is 20. 0 times 6 is 0, minus 4 times -2 is -8, plus 0 times 5 is 0, minus 2 times -2 is -4. And you simplify it and it gives your answer. Remember, when you're doing determinant, you cross, minus always, cross. So this would be 2 times -8 minus 3. That's a double negative. Double negative. -16 minus 24 minus 4.
What if you,
So your answer is -44.
what if you put the 8 in front of the 0, like yours says 0 plus 8?
You have to go this way. That minus that way. That's the formula for determinant. Just like what we did up here. You got to go straight like that, minus, then the other way. That's the formula for find determinant. Yes.
What is the determinant? Like, what is it?
It's just another operation. You know how like we have adding, subtracting, multiplying, they don't have division? That's like its fourth operation. It's finding a determinant. And you're going to use that to help find the inverse in a minute. All right, how many of y'all like this way better than the slash way?
I don't have a slash.
You forgot. This slide. Well, if you remember, you can do it that way, but I just don't. I never could understand that when I was in high school. All right, next one, number 5. And tonight, I'm going to look at these checkpoints to see where you're messing up. I'm going to write you notes so we can learn from our mistakes by tomorrow. But you got to come in 0 period to finish it because you got a quiz on it tomorrow. Now, if you get home and you want to, if you did not finish that checkpoint and you get home and you want to watch a video and do that check, I put the checkpoint on the video and work on a piece of notebook paper and figure out, you can bring that to me. All right, what's your first number you're dealing with? 1. What 4 numbers I'm going to choose? -3, 5, 2, and 3. What always goes next here? Minus 2. I'm going to choose these 2 and these 2 because it's not in the same row or column. Now I'm going to find the determinant of each of these 2 by 2. -3 times 3 is -9. Minus 2 times 5 is 10. Minus 2. -2 times 3 is -6. Minus 2 times 3 is 6. Plus 5. -2 times 5 is -10. Minus a -9. What did we get? 0, I believe. So the main takeaways from here, while you're letting it marinate, is in a 2 by 2, slash that way, always minus, slash that way. 2 by 2 is easy. 3 by 3. A couple things by 3 by 3. You start with this number, put it here. Make your 2 by 2. The numbers cannot be in the row or column of that one. What always goes here? Minus the next number. The 4 numbers right there. Then plus.
Why is there a plus there?
Why is there a plus right here? That's the formula for it. There's a formula. Always minus and then plus. Always minus, then plus. Are there any questions? Yes.
I don't understand like the signs, like how you're getting like -9 and -10.
Where's negative 9? Negative. Okay, right here. You multiply negative 3 times 3 is negative 9. Always minus goes there. Like right here. Didn't we always go cross, minus, and then, because it was 18 minus a negative 6. That's the formula. Okay, so then minus 2 times 5 is 10. Negative 2 times 3 is negative 6. Always minus goes in parentheses. 2 times 3 is 6. Negative 2 times 5 is negative 10. Minus negative 3 times 3, which is negative 9. That became a plus because that was a double negative. All right, let's look at our second learning target. We're going to find the inverse. This is the last thing that's on your test Thursday. We're only going to find, what do you notice about all these matrices? They're only what? 2 by 2. So we're just going to find the inverse of 2 by 2. All right. We want to find the inverse of this number 1 here. The first thing you'll do is determine the determinant. Okay, so we're practicing what we just did. What's the first thing we multiply? 2 times is, what always goes here? 1 times 5 is, so your determinant is 1. If you get a determinant of 0, then there's no inverse. So if you want to write a note there somewhere, if you get a determinant of 0, it has no inverse.
What is negative?
It's fine if it's negative. Just if it has 0, it's no inverse. Once you get the determinant, guys, once you get the determinant, you put 1 over what you got. What did I get right here? I got what? 1, so I'm put that there. Always put 1 on top, and then whatever you get for the determinant there. Here's the rule. You flip the spots of these two. So that's going to be a 3, that's going to be a 2. Does everybody see that? I flip the spots. You change the signs of these two. 5 will become negative 5, 1 becomes negative 1. And what's 1 over 1 equal to? So you just distribute that 1 to everything. So your answer is that. That's your inverse. You said, what is the point of this? Okay. If I took these two matrices, guys, and I multiply them together, I will get something called the identity matrix. And the identity matrix looks like that. And that's an important matrix if you go on into math and study later on. What would the identity matrix look like in a 3D? We're not doing that in this course, but you see how the diagonals of 1s? And you remember the identity property in middle school, like additive identity or multiplicative identity? Anything multiplied by 1 is itself. All right, let's look at number 2. First thing I'm going to do is find my determinant. Negative 3. What's negative 3 times 3? What always goes here? Negative 5 times 2 is? This is double what? So I'll get 1 again. So I'm going to put 1 over. What did I get? 1. It's not going to be 1 every time. I'm just find one that's not 1. You put 1 over what you get. Okay, so if it was a 9, you put 1 over 9. If I got 9 as my, 1's always on top. If I got a determinant of negative 9, I will put negative 1/9 outside of it. Okay, does that make sense? You would multiply. If I had negative 1/9, I would distribute a negative 1/9. I'm going to find one in just a second. Okay, what do I do with these two right here? Flip them. This is going to be 3 up here. This is going to be negative 3. And then I change the signs of these two. Negative 2 and 5. If I multiply everything by 1, that's what I get. Let me find one here.
The next one is.
Next one's 1. Number 4 is 1. Number 5. Let's look at 5. 7 times -5 is what? What always goes here when doing determinant? Minus. 4 times 8 is? What's 35 minus 32? So I'm going to put 1/3 out beside my matrix. What do I do with these two? Flip the position and then change the signs of these two. So now my identity matrix, 1/3 times -5, I just put -5/3. Don't give me a decimal. -8 times 1/3 is -8/3. -4 times 1/3 is -4/3. And then -7/3. And that would be your answer. We're not learning anything new tomorrow. We're just reviewing all this, okay? None of this is on your quiz tomorrow. The only thing on your quiz is systems and add, subtract, multiply matrices. 6 questions, so don't take a long time, and we can review. Okay, your homework is over here. I didn't want you to do a lot, so that's why I listed individual numbers. So you got page 11, number 17, that's another system. Like I said, if you get home and figure out what you did wrong at 2 points, just do it on a sheet of paper and I'll bring it to me. Page 12, numbers 4, 10, 12, 14, 13, 17, 18, 20, 21, 22. I didn't give you any inverses because we're in practice those in class, but determinants and practice. Yep, go. Yes. Yes.
Yeah.
Holly, come here. You just made a careless mistake. Come here.